Hello everybody. Well, first of all, welcome to my office. As you can clearly see, it really is a magical place. Today I have a logic puzzle for you. I have 4 cards. And on each card is a letter on one side and a number on the other side. Now I've shuffled them and laid them out, and they read DK37. And I'm going to make a conjecture about these 4 cards, and the conjecture is this. Every card with a D on one side has a 3 on the other. Now I don't know whether this statement is true or false. So which cards do I need to turn over to determine the validity of the statement? I could turn over all 4 cards and that would tell me whether it was true or not. But what is the minimum number of cards I need to turn over to determine whether the statement is true? Well, while you're thinking about that, let me describe another problem. 4 guys walk into a bar. One of them orders a whiskey, one orders a Coke, one is an older gentleman, and one is a young guy in a hoodie. And as you know, in a bar, everyone that orders an alcoholic drink must be of legal age. So who do we need to ID? Well, it shouldn't be too hard to see. We need to ID the whiskey drinker and the young guy in the hoodie. It's irrelevant to ID the Coke drinker, and the idea is the older guy is clearly over age, so we don't need to ID him. Well, this principle can be applied to the problem behind me. Which cards do we need to turn over? Well, let's go through them one by one. What about D? Well, it shouldn't be too hard to see that if D had another number other than 3 on the other side, the statement would be false, so we do need to check D. And in this case, D has a 3 on the other side, so far so good. Now what about K? Well, just like in the other problem, K is in fact irrelevant. It doesn't matter what's on the other side, we don't need to check it, we can. It has a 1 on the other side, doesn't matter. Now what about 3? Do we need to check card 3? Well, this statement is in fact an if and then statement in disguise. So, if a card has a D on one side, then it has a 3 on the other side. The implication is in one direction. So in fact, it is irrelevant what's on the other side of this card. It could be D, could not be, doesn't matter. In this case it's P. And what about card 7? Do we need to check card 7? Well, if you think about it, if 7 has a D on the other side, then the statement would be false. So we do need to check it. And in this case, it does have a D, so the statement is false. I could have used this card, which has an R on the other side, and the statement would have been true. The cards we need to check then are D and 7. How did you do? Well, in many surveys, they have found that about 10% of the general public get this question correct. In fact, a recent survey found, again, that 10% of the general public got this correct. 29% of mathematics undergraduates got the correct answer, and only 43% of mathematicians themselves got the correct answer. So how did you do? Are you smarter than 57% of mathematicians? Let me know in the comments below.